Hmm. Hello everyone, how are you all?
I'm fine, Apurva. What about you?
Yeah, I'm fine. So, did anyone else still not believe that RCB actually won this time?
Yeah, every season it's Isala Cup Namde, but this time they actually pulled it off.
It made me think that if we had all the IPL data nearly stored, we could actually track these comebacks, teams, forms, and players' states so easily. That's why our project is all about designing a smart IPL database that helps make a sense of this all this direct cricket chaos. So I request Bhagya to present the screen. So, today our subject is fundamental of database DBMS management system. So, our topic is IPL T20 database. So, the Indian Premier League is one of the most popular data rich T20 cricket league in the world. So, here you can see IPL T20 database design a data driven approach. This presentation outlines a robust database design for Indian Premier League T20 cricket data. It enables comprehensive analysis and strategic insights. We will cover all the objective, schema, sample data, and query example for in depth understanding. So, every match generates a massive structured and unstructured data from a player performance to teams formed and the venue, match outcome, and engagement of metrics. So this project title, that is T20 IPL T20 database design, aims to build a robust relation database that can efficiently store, organize, and support real-time tracking, historical analysis, and predictive modeling. So this provides a solid foundation for data analysis, reporting, and intelligent decision making. So the next is so coming to the objective and problem statement. So we have three major components in this: objective, problem, and need. So the objective to design a robust relation database for IPL T20 match data. This includes identifying the key entities like teams, players, match, and venues, designing their attribute and defining the relationship among them to ensure efficient querying and analysis. Next comes the problem. Existing data is disparate, inconsistent, and difficult to query. So currently, IPL data is often stored in disparate sources like websites, spreadsheet, and APIs,
ಒಂದು ಹದಿನೈದು
which
ನಿಮಿಷ
are inconsistent, unstructured, and difficult to query directly. This makes the data analysis time consuming and unreliable. So, what is the need we can implement in this? A structured database for real time tracking, historical analysis, and predictive modeling. This means that there is a strong need of well structured and defined database that can track match events in the real time, provide insight from past scenarios or seasons, provide support of predictive analytics, match outcomes prediction, player performance, and forecastings. So next, coming to the next slide. So here we have the conceptual schema, or you can call it as key entities. So as I've said, the key entities are team, player, match, and venue. So coming to the team, so this part of the project highlights the core components like of the database using entity relationship, that is ER model, which identifies the main entities and their attributes. So coming to the team entity, so team ID, that is, it is a primary key, uniquely identifies for each team. So next is the team name. This defines the name of the team, like if you it is RCB or Mumbai Indians or any other teams. Next is home ground. This the team primary stadium. So it justifies the stadium where the match is ongoing. Next, coming to the player entity. It has player ID, player name, nationality, and date of birth. Player ID is a unique ID for each player given. Next, player name. Full name of a player is given as a player name. Next, we have a nationality, the country or the origin of the player. Next is date of birth. Date of birth for age tracking in the matches. And next, at the last, we have a role. This is a player's role, that whether the player is a batsman, a bowler, all rounder, or a wicket keeper. Next, coming to the match entity. So it has match ID, match date, venue ID, team 1 ID, team 2 ID. Next, toss winner ID, match winner ID, match match play ID, result type. Next, the match ID. What does the match ID is also a primary key, uniquely matches the it is unique match identifier. Next, coming to the match date, the date when the match took place or will take place, and then the venue. Venue is nothing but it's a foreign key linking to the venue or the place where the match is going. Next, coming to the team 1 and team 2 ID, these are the teams that are participating in the match. Next, we have toss winner ID. So, the team that won the toss at the beginning of the match, it describes the toss winner ID. Next is match winner ID. This describes the team that won the match after it's been played. Next is man of match player ID. Player awarded as a man of the match. Next coming we have the player ID result type. The type of a result, normally win, tie or over, etc. Next we have the venue. The place, as I've said, where the match is ongoing. We have venue ID PK, that is nothing but primary key, unique venue identifier. Next we have venue name, that is stadium name. Next we have a city. You can say it's a location of the place where it is taken or location of the venue. Next, capacity. Capacity is seating capacity of the stadium, that how many people or how many uh, persons are accommodating in the stadium. So this schema helps to normalize the IPL data and ensures that relationships are clearly defined for a better query efficiency. Hmm. So this is the conceptual schema as I've told everything. So further, I request Chandrakala to continue and proceed with the further information.
Next slide. Good evening, everyone. As already Apurva said, introduction and information about the conceptual schema. Now I will be continued this topic. First, we know about the conceptual schema. In DBMS, the conceptual schema represents the logical structure of the entire database for a community of users. It is independent of physical storage details and focuses on what data is stored and the relationship among the data. And uh, this conceptual schema consists of three level of architecture. First one is the external level, conceptual level, internal level. In concept external level, user view will be there, and conceptual level, logical view. In internal level, physical storage. And in this we represent, I will tell some example. I will take a cricket match database. In the conceptual schema for a cricket database, entities are player, team, match, venue, scorecard, and relationships are team player and match team, match venue, match player, and attributes are run scored, balls spaced, wickets taken, and catches, etc. And first, we know about the difference between conceptual schema and physical schema. In coming to the conceptual schema, it is a logical structure and focuses on entities and relationship and independent on DBMS. And in coming to the physical schema, it is an actual data storage, focuses on files, indexes, storage, and it depends on hardware and uses DBMS. And finally, I will tell the conclusion about the part of the conceptual schema. The conceptual schema defines what data is in database and how the data elements relate to one another. And it is a high level design used to database designers and acts as a blueprint for creating the logical and physical models. And next one is the relationship in FDBMS. A relationship is an association among two or more entities. In the key points of relationships, it describes how entities are connected to each other and represent in ER diagrams and using diamonds or some other shapes. And relationships can also have a attributes. um, Types of relationships are one to one, one to many, one many to many. Coming to the one to one, it describes one entity of A is related to one entity of B. For example, one player can have one jersey number. And coming to the one to many relationship, it describes one entity of A can be related to many of B. For example, one team have a many players. And next, coming to the many to many, in many to many entities here of related to many of B. For example, players and matches. And next, in this slide, we observe relationships or team player, match table, and match venue and match player. In team players are many to many, and match team are many to many, and match venue are one to many, and match player are many to many. And next is next slide. And next we are move on to the logical schema and overview of core tables. Uh, Logical schema is the structured design of a database at a logical level. It defines how data is organized. It includes tables, columns, and attributes, data types, primary and foreign keys, and relationship between the tables. It is independent of the physical storage but more detailed than the conceptual schema. And the logical schema overview purpose is converts the ER diagrams into relational tables and helps developers to understand how entity are stored as a table and how data is linked using a primary and foreign keys, the structure used in a SQL database. And we include the core table in logical schema. We taken a cricket IPL T20 cricket example. In this first one is the team table. It consists of team ID. It is a primary key, and the next team name, and it is a unique queue, and the city, and the home ground ID. And next will be the player table. In it consists of player ID, player name, nationality, and date of birth, role. Next slide. Okay, next table is matches table. In this, it consists of match ID, season of year, and match data, and venue ID, team ID, and toss winner team, and the match player ID. And next table is player match status table, and it will consist of stat ID, match ID, player ID, runs scored, and balls faced, wicket taken, and run given over ball, and catches taken. These are the logical schema. So I will conclude this part, and next part will be continued by Bhavana. Thank you.
Good evening, everyone. First, let's look at the sample data for teams and players. We have a teams table. For example, team ID 101 is Mumbai Indians from Mumbai. Team ID 102 is Chennai Super Kings from Chennai. Team ID 103 is Royal Challengers Bangalore from Bangalore. Then we have a players table. It includes player ID 201 is Rohit Sharma from India, a batsman. Player ID 202 is MS Dhoni, a wicketkeeper and batsman. Player ID 203 is Virat Kohli, a batsman. Player ID 204 is Bumrah, a bowler. This helps us understand how teams and players are recorded in the database. Next, we move to the next slide, sample records, matches and player stats. In this matches table, each match has a match ID, date, team IDs, venue and result. For example, match 501 was played on 31st March 2023 between CSK and GT, and Rashid Khan was the man of the match. In the player match stats table, we track how each player performed in a match. For match 501, MS Dhoni scored 0 runs and has no catches. Rohit Sharma scored 41 runs. Bumrah have 29 runs and took one wicket. So each player performs is recorded for every match. Using this structures data, we can write SQL queries to find useful information. For example, to find the top 5 run scores in IPL 2023, if we use this SQL query, it joins the players matches and player matches stats table. It includes the total runs for each player in 2023. Then it orders the players by total runs and shows the top 5. This helps us get meaningful insights using data. Thank you. Next, we'll continue by Bhagya. Thank you.
Good evening, everyone. Myself Bhagyashri. So today I'll be presenting the DDL code implementation for designing a database system for the IPL T20 tournament as our project. This database helps the store and manage structured data about IPL teams, players, matches, stadiums, auctions, and individual performance. So let's present. So here, as you can see here in the code, create database if not exists IPL T20 database, use IPL T20 database. So here this creates the main container for all our tables. Use IPL T20 ensures that all the subsequent tables are created inside this database. So coming to the next, create table team. So here this creates the table named team and stores the details of each franchisee. Team ID is the unique identifier primary key. Fields are stored using varchar for text. ಸ್ಟಾಪ್ ಅಂತ ತಕ್ಷಣ ಒಂದೇ ಲೈನ್ ಹೇಳ್ತೀನಿ ನಾನು And the next table is player. So here each player has a unique player ID. It stores the key info like name, role, nationality, and date of birth. Here the data type used for date of birth is date. And next is table named stadium. Here each stadium is uniquely identified by stadium ID, which helps track where matches are hosted. Capacity is stored as an integer. And next is a table named match details, where this records individual matches, includes foreign keys linking to teams and stadiums, ensures referential integrity. Teams or stadiums must exist before a match is recorded. So next comes the table named auction. Here, this represents player auctions, tracks which player was bought by which team, in which season, and for how much. Uses float for price values. And the next is table named performance. Here it stores the individual performance stats per match, which is linked to player and match details tables using foreign keys. It helps in player analysis for queries like top scorer, most wickets, etc. So here are some sample records insertion. Here the values are inserted into the team table. Here the values are inserted into the team. Here the values are inserted into the table named player, and the values inserted in the table stadium, and the table match details values, and the values inserted in the table auction, and at last the values inserted at the table performance. Designed to avoid redundancy, ensured referential integrity using foreign keys, made the database capable of supporting real world queries like top scorers, auction prices, and dates. Database schema uses efficient relational design
to represent a complex real world scenario. So the last words will be concluded by Chandrakala.
So I will be concluded this whole session. This IPL database project reflects how database system bring structure, insights, and value to real world applications like sports analytics. Thank you.